Welcome to lesson 3.6, continue. The objective of this lesson is to solve system of equations using the elimination method. The first example that I would like to show you is the system of equation that consisted of two equations. Negative x plus y is equal to 4, x plus y is equal to 2. First thing I would like to do is to show you how I can find the solution by graphing. So I'm going to take the first equation. I'm going to rewrite that first equation into a y equals to mx plus b such that I could see the y-intercept as well as the slope. So what I will need to do is I'm going to add x on both sides of the equation to isolate y by itself. So the first equation is going to become y equals to 4 plus x. The y-intercept is going to be at 4, so let me put my first point on the y-axis at 4. This is my y-axis and this is my x-axis. All right. According to this equation, my slope is 1. So what that means is I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So let me just put some discrete point and I will go back and connect the points. So that's what my first line looks like. For my second line, again, I'm going to need to rewrite it as y equals, so I'm going to subtract x from both sides. So I'm going to get y is equal to 2 minus x. What this means is my y-intercept is going to be at 2, and the slope is negative 1. So what that means is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So if I connect the dots, the discrete points, this is what I'm going to get. So it looks like the intersection point is located at negative 1, 3. So the solution, the ordered pair, is negative 1, x equals to negative 1, and y is equal to 3. Let me show you a different method, the elimination method, to get negative 1 and 3. The elimination method is exactly how it sounds. What you want to do is to combine the first and the second equation in such a way that one of the variable will be eliminated. What I mean by that is I am going to take the first equation and the second equation and I'm going to add it vertically. Okay. When I add it vertically, negative x plus x, the x has now been eliminated. I'm going to get 0x. That's exactly what I want. I want to eliminate one of the variable. I have y plus y, so that would be 2y. Let me bring down my equal sign. I'm going to have 4 plus 2, which is 6. I'm going to solve for y by dividing both sides by 2. And when I divide it both sides by 2, you'll notice I'm going to get y is equal to 3. So there it is. There's my y coordinate of 3. Okay. Let me try a different way. Instead of adding, let me subtract. So let me erase what I have done here. All right. Now, instead of subtracting, instead of adding, I could also subtract vertically. All right, so here's what I'm going to get. I have negative x minus x, so that's negative 2x. I I have a positive y minus a positive y. So that will be eliminated. That has become 0y. I have a 4 minus 2, so that will be a positive 2. So you notice if I divide both sides by negative 2, I am going to get x is equal to negative 1. So there is my x coordinate of negative 1. Okay. Let me show you another example. Here's another set of linear system. The first equation is x plus 2y is equal to 6. I have 3x plus 2y is equal to 4. I could rewrite this to get y equals to mx plus b and start graphing it. But what I'm going to do is I'm going to subtract the top equation from the bottom equation. When I subtract the top equation from the bottom equation, here's what I'm going to get. I have 1x minus 3x, so that's a negative 2x. I have 2y minus 2y, so that has been eliminated. It's become 0y. Let me bring down my equal sign. I have 6 minus 4, so that's equal to 2. If I divided both sides by negative 2, I'm going to get x is equal to negative 1. All right. Once I have the x coordinate, then I can choose one of these equations and use substitution to find the y coordinate. I'm going to use the first equation. All right. Using the first equation, I'm going to replace x with negative 1. So I'm going to get negative 1 is plus 2y is equal to 6. Let me solve for y. So I'm going to add 1 to both sides. So I'm going to get 2y is equal to 7. Dividing both sides by 2, I'm going to get y is equal to 3.5. Right. So the intersection points between these two linear equations is going to be at x equals to negative 1 and y equals to negative 3.5. So somewhere about there. Let me try again on my third example. All right. So I'm looking at these two equations. My first one is x plus 2y is equal to 6. My second one is 2y plus 4y is equal to 12. Let me show you something really quickly. Even though these two equations looks different, they're actually the same. It produces the same line. And here's the reason why. Let me take the first equation and rewrite it as a y equal. So I'm going to subtract x from both sides. That leaves me with 2y is equal to 6 minus x. I'm going to divide both sides by 2. So my first line, my first equation is going to be y equals 3 from 6 divided by 2 minus 1 over 2x. So my y-intercept is going to be at 3 and my slope is negative 1/2. Let me take the second equation and do the same thing. I'm going to subtract 2x from both sides. I'm going to get 4y is equal to 12 minus 2x. I'm going to divide both sides by 4. And my equation will then become 3 from 12 divided by 4 minus 2 divided by 4 is the same as 1 over 2x. Okay. So even though these two equations looks different from the beginning, they're actually the same. The second equation is being multiplied by 2. Right, so keep that in mind. You can change the look of individual equations by multiplying it with a coefficient. Okay, so I'm going to use that same concept for this next